Hello and welcome to my COMP3331 assignment demonstration video. I'll jump straight into it because there's not a lot of time. But basically, and I talked about this in the report, this is the structure that each peer takes. So they have their main thread executing constantly, and then in the background there's a TCP server thread and UDP server thread, which they use to receive messages from other peers. And also each peer is constantly requesting messages from its successors to check that they're alive in the ping successor thread. And then there's the main loop where the peers basically just sit and wait until you give them an input in their command line, at which point they will run a task thread, which can be of many different types. It can be requesting a file or telling another peer about new successors, and it can execute that and then go back to the start of the loop and wait for more input. So let's jump into it. Here is my network of peers, and it's set up circular so you can easily see what's going on. Now keep in mind that peers are constantly pinging each other in the background. However, I only printed out one ping just because I didn't want the command line flooded with output. But each peer pings its successors once every second to check that they are alive. Let's get into file transfer. So we can see here there's a file called 88.pdf, and peer 56 wants to request that. So let me get all the peers up. Boom. Okay, peer 56 wants it. We type in 88. Typed in 88t. Not a problem. It can handle that. Lovely. Now what we expect to happen is 88 will send a message over TCP to 67. Its immediate successor, asking if 67 has the file. 67 shouldn't have the file, and so it will send a message to 80, once again over TCP. Keep going around until we get to 90, which should have the file. 90 will send a message over TCP back to 56 saying, hey, are you still alive? 56 will send a message back saying, yes, please give me the file. Boom, file transfer will happen. Let's see if that works. Lovely. So we can see here 67 is correctly identified that it does not have the file, sent to its successor, and then 90 keeps going around until we get to 90. Start sending the file is sent, file is received. Let's have a look. There's a file here called new 88. Let's look at that. New 88, lovely. And looks like all the bytes transferred pretty well. Pretty good job from my peers. Well done, guys. Let's get out of that. Yeah. Cool. And there was also responding and requesting text files, which I don't have time to go into and look at, but I'm sure you can have a gaze at those. They're, once again, pretty perfectly done. Okay, so next is peer departure. So for this, we'll simulate 90 leaving the peer, so you can start visualizing what might happen. So here, if we type in quit, 90 will inform its two successors 130 that it's left, and their predecessor will get updated, and vice versa with 90's predecessors. They will be informed of their new successors. Let's have a look. Lovely, left the network. My first successor is now 100. My second successor is now 130. Looks about right. Let's get rid of this so we can easily see. Yep, 100, 130. Likewise, 67 is now aware that it has a new successor, 100. And I have this functionality in here just for the demonstration. If I type in predecessor into a peer's command line, it will print out its predecessors. Predecessors are 80 and 67. Looks about right to me. And just for, I don't know, completeness, if we now request file 88, invalid input, good to know that works. 100 will identify that it is responsible for the file. Now that peer 90 has left. Cool. Well, what about if a peer leaves without it knowing that it's going to leave? For example, it disconnects. So let's pretend that 100 gets disconnected. Control-C out of there. So as I said before, these peers are constantly pinging each other in the background once every second. I set it up so that a peer is considered to have left the network or been killed if... where was I going with that? If a response message is not received 3 times in a row. So when peers send pings to each other, they have a sequence number as a part of that. If it's missed out 3 times in a row, a peer is considered dead, and a peer that notices its successor is dead, for example, peer 80, it's noticed that 100 is no longer alive, it will then forward its only other remaining successor, in this case 130, a request to ask for new successors, and 130 will respond with the new successors, and they will get printed out here. My first successor is 130, boom, looks right. My second successor is 56. Looks good to me. And 67 also has identified that it has new successors, a new second successor of 130. All the messages are correctly sent over TCP and UDP as required. I don't have enough time to go into my code and show you that. But yeah, pretty bang on assignment. I did some really cool stuff, which I encourage you to read about in my report, about immutable objects in Python and basically trying to get pointers so that I could communicate variables between threads. A little bit of a hacky way. I was pretty proud of it. Did a lot of Googling. Please have a look at that. Thank you.